In this problem, we want to assume that x and y are both differentiable functions of t. Use the given values to find dy dt and dx dt. So we'll find derivative of y with respect to t and derivative of x with respect to t. Now our equation is y is equal to the cube root of x. So we've got y is equal to the cube root of x. Now we don't want to leave it in radical form, so this would be x to the 1/3 power. Remember, whatever number's in the slot, that's your index, that goes in your denominator, and then you put a 1 up on top. Well, we'll take the derivative of everything where it's sitting. Well, the derivative of y is 1. You take derivative just like normal. Actually, let me write out that step. I was going to skip some steps. Okay, I want to take the derivative of everything where it's sitting with respect to t. Okay. Well, the derivative of y is 1. We take derivative just like normal, but we were taking the derivative with respect to t. So we have to add on our dy dt. You always have to add that on if you're having different variables like that. Now over here, x to a power. We're going to take the derivative just like normal. Take our power, put it out in front, lower it by 1. But since we're taking the derivative with respect to t and it's really an x, we had to put on our dx dt. Okay, so that gives us dy dt. We got 1/3 x to the negative 2/3, 1/3 minus 1, dx dt. So I got dy dt equals, and I'm going to take that x to the negative 2/3 to the denominator, becomes x to the positive 2/3, dx dt. Okay, so that's our equation we're going to be working with. Part A. We've got dy dt is equal to 1 over 3x to the 2/3 dx dt. Now they want us to find dy dt when x is equal to 8, so they're telling us x is equal to 8. So wherever we have an x, we'll put an 8 in. And they tell us also dx dt is 5. So we'll put 5 in for the dx dt. And we're wanting to find dy dt. Now, 8 to the 2/3, that's 4. Times 5. 3 times 4 is 12, and I'll put the 5 up on top, so that gives us 5/12. And that's our first answer. Let's say you looked at the 8 to the 2/3 and you're like, well, where in the world did that come from? How do you get 4? On your calculator, you can calculate this. 8, and then I'll do a caret. That's how you do a power. Now, whenever you have more than a single number or single variable up in your exponent, you want to put parentheses around it. So when we plug this in, we'll put a beginning parentheses, 2 divided by 3. And I'll put a closing parentheses, though you don't need closing parentheses at the very end, and then we press enter. And you see it gives us 4. So you can use your calculator to do that if you want. Now, if you are curious how to do it by hand, love of math has taken over in your life. We got 8 to the 2/3. We got a property from intermediate algebra, algebra 2, that says if you got a fractional exponent, rational exponent, you can take the number up on top in the numerator and put it on the outside set of parentheses. So this would be 8 to the 1/3 to the second power. Now 8 to the 1/3 is the cube root of 8. We can put it back in the radical form. Whatever number is in your denominator, that's your index. Now 8 is 2 times 2 times 2. Now our index is 3, which means we're looking for a set of 3 of something. Here's 3 2's, so that's going to come out in front as a single 2. So we're going to have 2 squared, which gives us 4. So that's how if you were wanting to do it by hand, you could do it. Okay, part B. Let's go back to this original equation. We got dy dt is equal to 1 over 3x to the 2/3 dx dt. Let's see what B says. B says x is 27. So we'll put 27 in for x. And it says dy dt is 3, so this side is 3. And we're actually trying to find dx dt in this one. Okay, well, let's do a little bit of simplifying. 27 to 2/3 is 9. dx dt. And again, you could go through the calculator or by hand to verify that. That's 1 over 27 dx dt. We're trying to get to dx dt by itself, so we'll multiply both sides by 27. 27 times 3, and then 27 times 1 over 27 dx dt. 27 times 3 is 81. Those 27s cancel, and we got dx dt. So that's our other answer. And those are the two parts that are wanting on this particular problem.